Hello, it's Colt again, still here, haven't totally lost my mind yet. And in this video, we're talking about set comprehension. So I kind of lied in the last video by saying that there was only 2 videos on sets. I kind of made the decision halfway through the video that it was getting too long and that it would be better to split it. So alas, here we are with 3 set videos. I'm sorry for deceiving you. Set comprehension is the same idea behind list comprehension and dictionary comprehension in that we can very rapidly create sets using sort of a shortcut notation. We can copy sets or manipulate them and make new versions where we operate on each item in the set. So here's a simple example. Notice we use curly braces just like we did for dictionaries, but there's a key difference. We don't actually specify a key : value. We only specify one thing. So it's not neither the key nor the value because it's not a dictionary, it's a set. So it's just the item in the set. So in this case, x squared, 4x in range 10. So that's going to go from 0 up to 9 and square it each time and add it to the set. And you can see that there's no order still, it is a set. And we go 0, 1, 64, 4, 36. However that's established, I don't know. But let's test it out. There we go. That's our first simple set comprehension. And just to showcase the difference, just by doing this here, x : x squared, 4x in range, what do we get? Now we get a dictionary, as you can see here, where we have a key of 2 and the value is 2 squared. We have a key of 3 and the value is 3 squared, which is 9, and all the way up. So just by adding the key : then we end up with a dictionary, but if we only have one piece of information, it assumes that it's a set. So here's another example. Let's do char.upper, just like that, for char in, and then we'll do a string, but this string will have some duplicates. So let's do, hello, like that. There's 2 L's. What do we end up with? Well, we end up with one of each character uppercased. So because it's a set, those duplicates are not allowed, and also the order is all messed up. So I have one more example, and this one might be a bit scary. This is actually a function which we haven't learned about yet, but I put it here because it's where we're going next. So in the next section, we'll be able to make more sense of this. But what this does is it takes a given string, whatever we pass in, any string, and it will return true or false depending on if that string contains all of the vowels, A, E, I, O, and U, all of them. So not just one, it has to contain all of them, and if it does, it returns true. But to start, let's just analyze this bulk of the logic, none of the function syntax. We'll come back to that. So let's define a string first. We'll just call it string, and let's start with, sure, hello, that's fine. And then let's take a look at what's happening here. And let's even simplify this more and just focus on the set comprehension. So what's happening? Okay, we are creating a set character for each character in string if the character is in A, E, I, O, or U. So we're basically just pulling out the vowels from a word into a set. And you can see from this string, we end up with E and O. Those are the only 2 vowels. And if we could change string to be hello, ha ha ha. And if we rerun this, take each character, put it in a set. If it's one of these, we end up with A, E, and O. So to tell if a string contains all 5 vowels, we could just use this exact same logic, but check if the length of this resulting set is equal to 5. So in this case, if we just do len of that same set comprehension, we end up with 3. And we want to check if it's equal to 5. If it equals 5, it means it contains, whatever the string is, contains every single vowel. So a word that does contain all 5 vowels is my absolute favorite tree on earth, the sequoia tree. So we can do string equals, see if I can spell it correctly. It's just a jumble of vowels at the end. If you haven't seen these trees online, check them out. Pictures don't really do them justice. They are so massive. They're the largest living things on earth. If you are able to see them, if you live anywhere near California or you're out here at some point, definitely check them out. They're so awesome. Like I said, pictures do not do it justice. You just have to be there. It's pretty awe-inspiring. Okay, more importantly, this is a word that contains all the vowels. So now if I try this, We get true, because if we look at what set is generated, it contains all the vowels, and we're checking if the length of that set is 5. All right, and with that, we are done with sets, also done with tuples. Let's just quickly review what we covered. So, tuples, or tuples, are ordered collections of elements, and they are immutable, meaning they do not change. You make them and you leave them how they are. And again, there's an order. Tuples are faster than lists, and they're useful. Sets, however, are unordered collections of unique values. So there is no order guaranteed. There's no order at all. And they are not immutable. We can add and remove using the methods add and remove. Sets and tuples can be created either with the curly braces and parens, or the set or tuple function respectively. And finally, set comprehension is something we can do. It's useful if we're trying to convert other data types to a set. Like we saw, we converted a string to a set by pulling out the vowels, or we could convert a range to a set, and so forth. So that's it for tuples and sets. And now we get to move on to a big, important, exciting, awesome topic called functions. So I'll see you then in the next section, unless you quit. But I hope you don't.